Hello everyone. Let us solve the second problem of the continuous beam. So this is the problem we are going to solve. So first you double click on Staad Pro software. Next you click on new project. Next you select plane. Next you give the title continuous beam second one and the location. It is same yesterday's location only. And you need to see meter and kilometer is there. Then you click on next. Then add beam is there. You click on finish. Now you are seeing this grid view in 3D view. So you select the front view. This is x-axis, this is y-axis, and this is the z-axis towards you. And now let us see the problem. So the total span length is 5 plus 3. It is 8 meter. Two beams are there. AB one beam, BC one beam. So 5 plus 3. So it will come in this grid only. So first click on 0. Next you click on 5. Next click on 8. Then you click on close this one. Now you can see the line has been created of total length is 8 meter. If you want to see the span length means you click on this one and you click on display. So now you can see the span length. This is 5, this is 3. To remove this one, you click on this one. Again this one remove, close. So now you can see three nodes, 1, 2, 3 nodes and two beams. This one and this one. Now you have to assign. Now this is just a line and this is just a point. You have to assign for this line the beam property, and for this node you have to assign the supports. So next you click on general. Next click on define. The beam is always of rectangle shape. So you select rectangle. You give any dimension because you are doing only analysis, not the design. Whenever you are going for a design part, you'll get to know whether the depth and breadth are sufficient or not. So now we provide this one as again 0.4 and it says 0.35. Then click on add. So you can see the rectangle of dimension 0.4 by 0.35. Material is concrete. So now you assign this one to the this two beams, two lines. So use cursor to assign. Click on assign. Now you can see the change in the cursor. You click on this one and on this line. So now it is assigned. Now if you want to see the node numbers, you press shift N. If you want to see the beam numbers, you press shift B. So if you want to remove again the beam number, shift B. If you want to remove the shift node number, shift N. So let us keep the node numbers. Okay. So if you want to see the beam is assigned or no, you click on the 3D rendered view. So now you can see the depth and breadth both are assigned. So now you assign the property. Next you have to assign the supports. So which are the supports are there here? This is fixed. Here is fixed and this is simple support. So you click on general. Here support. You click on support. Create. First you create the fixed support. Next is pinned support. Click on add. Close. Now you want to assign this one to first node and the third node. So use cursor to assign. Click on assign. Take this one. Click on first node and click on third node. Next take the pin node and click on the node 2. Now we have assigned the property and the supports. So what is the next step? You have to assign the loads. One is UDL, one is point load. So this is the member load and this is also member load. It is acting on the BC member and this is acting on the member AB. So click on the general only. Here loads and definitions are there. So click on lowercase details, add. So you give the name title for that one, lowercase 1, add close. Next you click on lowercase 1, click on add. Now you can see the options here. As both loads are member load, click on member load. One is uniform load is there, uniform force. This is 60. It is acting downward, so it is minus 60. So it is acting along y-axis, that is downward. So D1 and D2 are 0 because it is starting from the first node and it is ending at the B node. So here D1 is not there, D2 is full length. So click on add. Next another point load is there, that is concentrated force point load. This is P. So what is the concentrated load is there? This is minus 90 acting downward. So it is at a distance 1 meter from the B, that is D1. So it is minus 90. D1. D1 is 1 meter. Click on add close. Now you have to assign this one. Now it is still a question mark. After you assign, it become green. So click on this one, use cursor to assign. Click on assign and click on the respective beam on which you have to assign. Next, you have to assign the concentrated load. Already assigning is there. On this beam you have to assign. So now it is assigned. So next click on close. Now if you want to see again the load, means you click on this. So as this is scale is very big, you make it small, and here you are unable to see the load value. Click on right click labels, click on load value. Okay, next is scales is there here. So this is UDL and this is point force is there here, this one. So point force, let us increase the scale for 10, and let us by still it is big, still it is not big, become less. So scales 0.4, euro value 50. Okay, now we can see the length has been shortened. So now the load is, this is 60 and this is 90. If you want to see the dimension, means you click on this one, display. You can see this is 5 meter, this is 1, this is 2, this total is 3 meter. Now we'll remove this one. So now you have assigned all the properties. Now next step is you have to analyze the beam. Analysis and print. You are not giving any the print here, so only no print here. Click on add close. So here it is asking for perform analysis. Click on analyze, run analysis. So it will ask save. So if you save, so here error should be 0. Next you click on go to post processing mode, then done. Next the load case, the loads are in this case, so take you select that one and click on OK. So increase this one. So now you have the deflection button is on. So if you want to see the deflection, you increase the size, scale of this one. You hold the control button on your keyboard and rotate the cursor in your mouse. So now you can see the deflection. The beam has been deflected like this. So to view the results, click on results, view value, beam results, to the displacement, annotate, close. Now you can see the deflection value. Here it is 2.973 mm and here it is 0.258 mm. So to take the picture of this one, click on edit, copy picture, then you can paste on the in the paint. So control V. So you have pasted here. You have to save this one, save as JPG. So let us view this one as continuous B, second one. in deflection. This second problem deflection JPG. So it is saved now. So next, if you want to see the bending moment, click on bending moment Z. So here results, view value, beam results, ends and midpoint, close. So now you have to verify whether these results are correct or no. So let us see the values. So here it is 140.94 is there. So here it is 140.95 kilonewton per meter. Here it is 92.675. Here it is 93.12. Plus or minus 5% error will be acceptable. So here it is almost zero here, this point. So this is the positive bending moment, and this is negative bending moment. These are negative bending moment. So only for this value we are designing this one. So here it is 70.688 is there. Here it is 70.47. So here you are seeing you have drawn the bending moment only on the vertical y-axis, but actually the sagging means it will be downward like this. Hogging means it is the beam will go upward like this. So next again, if you want to take the picture, edit, copy picture. Next, Control V in the paint. Next file, save as JPG. That is continuous beam bending moment. You change this one as second problem bending moment. Click on save. Next third one is shear force. Click on F5. Next you click on edit. Sorry, results, view value, beam results. You remove this one. Shear force at the ends and midpoint. Next click on annotate. Close. Now this is the shear force diagram. Click on file. Sorry, edit. Copy picture. Control V in the paint. File. Save as JPG. Continuous beam shear force. Change this one as second one. Save. So this completes the second problem. So now let us go for the third problem. So here a continuous beam is there, ABC, fixed at A and C, simply supported at B, consists of spans AB and BC of lengths 4 meter and 6 meter respectively. The span AB carries a uniformly distributed load of 20 kN per meter, while the span BC carries 12 kN per meter. Find the movements and the reactions at the supports. Draw also bending moment and shear force diagram for the beam. So to start with the new project, click on File, New. Next again select Plane. Next you give the name continuous beam. Third one, file location, and the units are meter and kilometer. Next click on Next, Add beam, Finish. Next you choose the front view. Next the span length is 4 plus 6, total it is 10 meter. So here total length is 10 meter is there. First beam is length is 0 to 4. Next is 4 to 10, it is 6. So next you click on close. So now you can see the line has been created with 3 nodes. So now you have to assign the beam property for this one and the support property for the node. Geometry, sorry, general, but that is property. Here you can define the property. That is rectangle, you give any dimension point, I will choose 0.35 by 0.35. Click on add, close. Next you assign this one to the beam. Use cursor to assign, click on assign this one and this one. Okay. Next if you want to see this one, you can see this one is assigned 3D rendering. Next, if you want to see the numbers or no numbers, shift N. We have to assign the supports for the nodes. Click on support. Supports are fixed and pinned, fixed and pinned. So fixed support at 1 and 3, 1 and 3, and pinned at node 2 and close. Now you have to assign the loads. So load case details, add load, give the name load case 1 or else any name, whichever your choice, add, close, load case 1, add. So these two are member load 20 and 12. This is acting downward, this is also acting downward, minus 20 and minus 12. Member load uniform force minus 20. It is acting over full length, global y axis, add. Next, minus 12, global y axis, add, close. This one you have to assign for the this beam, and this one you have to assign for the this beam. So now you want to see the load value, click on right click on this window, click on labels. Next, click on load value, apply. Okay, now you can see the value minus 20 and minus 12, minus 20 and minus 12. Next step is analysis and print. Now print, add, close. So it is asking for perform analysis, analyze, run analysis, save. Now you can see zero error here. Go to post processing mode, done. Next, the loads are in this load case 1. Click on load case 1, load, okay. Next, the deflex button is on. So increase the scale, control and scroll the button upward. So this is the deflection. So to review the value, click on results, view value, beam results, displacement, annotate, close. So you know how to take the picture of this one. Next, bending moment. So to view the value, results, view value, beam results, and bending midpoint, annotate, close. So increase the size. So these are the hogging bending moment. Negative bending moment. This is a positive bending moment. This is negative bending moment. So let us verify this one. So this is the bending moment. This is 23 point. This is 37.87. This is 37.863, and this is 18.93. 18.945. So it is correct.